appears to be bigger. Am I right?
Yes, sir.
Yes, sir.
Please remember, whenever your teacher is using the words, you need to be very careful. Appears to be bigger. ऐसा हमको दिखता है, लेकिन in reality it is not become bigger. Just it appears. ऐसा हमको दिखता है, but in reality it's not bigger. Just it is because of the phenomena. It is due to a one phenomena of light, what called refraction. It is due to refraction of light, this lemon appears big in size better. So, have you noticed that? Sometime, look at this. You see that your pet, you are having that like aquarium, this one. Your pet cat is something is just behind that. What happened to the size of this one of this fellow? Is looking bigger, no?
Yes,
Yes, sir.
sir.
Yes, sir, no?
Appears to
Yes, sir. Yes,
Yeah.
sir.
And sometimes you might have observed that our sun is there, no? sun. Okay, sun, our source of light. Sometimes better this our sun is appear to be big in size, and sometimes it appears to be a moderate size, and some other time this fellow will appear to be bigger. Have you noticed or not?
Yes, sir.
Tell me when our
yes,
sun appears bigger.
During the sunrise or sunset.
Wonderful, wonderful, my dear child. Wonderful. During sunrise and sunset. Very good, very good. During sunrise and sunset, my dear children, it appears to be bigger. Why? Why it happens? Then a physics student, you need to explain, sir, it is because of refraction. Just I have shown this one. Look at this. What happened to lemon? The lemon appeared to be bigger, alwa? Yes or no? The lemon
Yes,
appear
sir.
big in size. I told the word appear to be bigger. Similarly, our sun also appear to be bigger during the sunrise and sunset, and wonderfully given answer by one of the students. Fine, better, very nice, better. Thank you, better. See, this what what happened. So as I told you, your teacher told refraction when it happens, when the light bends. This is a question again. I am repeating. When the light bends, when it goes from one medium to, tell me,
Another
one
medium.
medium
Another medium.
to
Another medium.
another medium. Very good, fantastic. One medium. Right, good, better, good, better. Look at this, better. All of you have a glance, my dear children. So what is happening there? See, our sun is, very, very, very far. This fellow up to very, very far distance. And say our Earth is somewhere here, somewhere it is very small. And Earth is having, our atmosphere. So light from the sun, just as per your sixth class atmosphere, correct. But remember, but in a given medium. ये हम नहीं बताया सिक्स क्लास में. Okay, now we are telling you now 10th class. So from the so that means from the sunlight, it comes straight. It comes like this, a straight line it will come. The moment it enters the atmosphere, okay, Earth is having thicker atmosphere. Do you agree with me?
Yes, sir.
Yes,
Yes,
and Earth is also having a different layers of our atmosphere. Your science, your my social science, will discuss what is meant troposphere and stratosphere like that. So, can you tell me? Your teacher just now told when light goes from one medium to another medium, what happens?
it bends.
The light
It
bends.
bends.
it
Very
bends.
good. Very good, fine, fine. It is because of this bending of light, that fellow, our sun, appears to be a little bigger. You see, I have projected one more, example in the slide. See, one beaker is there, beaker is having a coin. We kept one coin in the beaker, almost in the central, middle of the beaker. Now, if you look at obliquely means what? Side view. Obliquely means capital side view. If you look this coin, this side view, not top view. I'm not telling top view. Not normally, just observe normal view. There's a side view, oblique view. What will happen to this point size? Can you notice?
It appears to be bigger.
Wonderful, my dear children. It appears to be bigger. This can be explained the phenomena of what is it called? Refraction of
Refraction.
yes, refraction of light. Okay? So the idea, the basic idea, what I want to bring to my children. Number one, when light goes from one medium to another medium, what happened to light?
It bends.
It
It bends.
bends, very good. And it is because of bending of light. Here the pencil is not bended. So pencil appears to be bending. I will just I'm stressing this word. Pencil appears to be bending because light is bending and moving, right? So and let us not go for a boring one, and let me just show one video, a little video, and we'll come back to this one. A simple video I will
Sir,
show. Amma, tell me.
sir, we can see the sunlight with our eyes without any hesitation during the sunrise and early morning and sunset. But we can't see the sunlight at afternoon, that time
Yeah,
and all.
yeah,
Why is it, sir?
yeah. Very good question, beta. Very good question. I will attend to you, beta. Don't worry. I will attend your wonderful question. Very great, good question. I will attend to that. Okay. And before that, let me just give this one. Now, all of you, you have to confirm that is you are able to see the screen.
Yes,
Yes,
sir.
sir.
Yes,
Now,
sir.
yeah, just listen to me. Little bit sound is there. I try to avoid, but let us see. Class is there. Can you hear the sound of the video? I think it is little less,
Yes, sir, it is little
Yes,
less.
sir.
but try to listen that one. So these are all my students, and yesterday they have performed these activities. I want to show to you. Please concentrate better. Dear children, I hope you have seen that video.
Yes, sir.
Yeah, yeah, yeah. So I think I'm sorry I could not give that voice properly. Little bit, at least you understood.
Yes, sir.
Yes, sir.
Okay, better.
Yes,
Thank you,
sir.
better. Thank you very much. Thank you very much. Now, this through activities and and the students they try to explain, you know, and why that is through activity. They're telling about that how the refraction happens, the bending of light. In the similar way, we can explain the concept. This is somebody one child asked the question. Better, I will definitely answer to you. Don't worry. This advanced sunrise, fine, and delayed sunset. Advanced sunrise and delayed sunset. Okay. So this is a you call a sometime in the reality what happens. This is called horizon. We use the word as a horizon. Horizon means in the simple language we can say that parallel the plane with respect to observer. A plane. Suppose you can say I'm just an observer and you imagine a line a parallel to that. So actually, it is a real position. That means sun is actually our sun is below the horizon. Is below the horizon means in reality we should not see the position of the sun. We should not see the sun because it is even below the horizon. But what happens due to the effect of refraction? We heard about that when light goes from one medium to another medium, it bends. So when it bends, you know what happened? So it bends here and reaches the observer as shown in the figure. I'm just showing this way. But our eye is there. No, our eye beta always perceives. Okay, our eye always perceives light is coming along straight. So, for our eye, for an observer, what happens, the light, what is reaching him, what the light is reaching her, this appear to be coming from a straight line path. So this fellow, for this observer, what happened? The light appears to be coming from this position. That means the sun is here. The position of the sun is changed now. Slightly is advanced sunrise. So we call it as what? A little bit advanced. Little bit earlier our sun will come. It is difficult for us, no? Because your mom and papa will make you up. Hey, get up. Already sunrise is over. Why you are sleeping? You see how much time like that. But don't worry. This physics is only disturbing you only 2 minutes. This sunrise, actually 2 minutes earlier, we can see our sunrise 2 minutes earlier and delayed sunset. Even you say here during sunset also, though the sun is set in reality, so sun setting is over. Sun has undergone below the horizon, underwent below the horizon. Even then to some time, as I told you, the sometime is 2 minutes, because of the phenomena of refraction, this fellow is seen. Our sun is seen. In really, it is underwent sunset because it is due to the phenomena of refraction. So we can explain, beautifully. We can explain, the concept advanced sunrise and delayed sunset based on the concept of refraction. Okay, this is one idea. Now, another thing is that. So let us understand better through an activity as I told, no advanced sunrising. So what the materials required? So here one video I will show, but before that I will explain. So what we will say, I will explain so that the video you can concentrate more. So one bowl taken, the two students, they taken one bowl. They don't, it's like a snacks bowl. You can also do this. After my class, you can also perform this activity, and if possible, you make it a video also. You ask your brother or sisters to take this activity video and please send to me, and I'll be very happy. So take one bowl, a small bowl, a plastic one or something, and keep one object. Let us you tell you keep one object or coin, preferably a 5 rupee coin, little bit thicker. So take a bowl and tell one bowl you take and keep a coin almost at the center of the bowl. Any object can be. So here you can take preferably a coin. Now you tell no, this is, let us take is kept on the table. Imagine it is kept it on the table, right? All of you, please listen to the activity carefully And you tell your brother or some fellow, just observe the coin. The coin is seen. You confirm that whether the coin is seen, observed by this fellow, your friend or your brother. And your brother says, yes, it is coin is visible. And tell your friend to move away, slowly move away and away from the position. Again, each time you ask your friend, coin is visible or not. So, one particular distance, your friend says, one particular distance from this, one particular distance, your brother says, your friend says, coin is not visible. That means, the light, is coming straight. Till that, from the source, I told you light is traveling along a straight line. A particular distance, if say, your friend says, no, coin is not visible. That means a step, if we keep away from this position, let us say this position, he is unable to see the coin. A step ahead, moving forward, he is able to see the coin. That position he has to stand. Okay, you tell your brother or your sister, whoever may be there in the home, and this activity. So tell him to just move away and away from this bowel and observe the coin continuously in one position. Say the position is X, coin will not be visible, coin cannot be seen. Okay, and tell your friend to be there only. Now you pour some amount of water, add some amount of water. What you have done? You changed the medium. Previously what was the medium? Air. Now what is the medium, beta? Water. Now the light is moving from water to air. No. What happens when light goes from one medium to another medium?
It bends.
It
It
bends.
changes.
Yeah, it
Bends.
undergoes what? Refraction. So what is happening there, The light undergoes refraction and the light will bend and reach the observer, right? Because of the bending of effect, your friend, where he is standing in the position X, X is the position of your friend, he can see the coin. That means, the coin can be seen. That means the position is there. Let me take here, this is the original position of the coin. Now, because of this, refraction effect, the coin appears to be, the position is changed. Let us take P1 is the original position. Now P2 is the apparent position. Previously, then the air medium is there, object is at P1. Now filled with the water, object is raised to, its position is changed to P2. This is what called apparent position because of the phenomena. What is the phenomena, beta? What is the phenomena called? Refraction. Okay. So now after listening to my, this one discussion, now we'll see the video so that you can easily follow. Right, beta. Have you seen that video?
Yes, sir.
So perhaps after my explanation, the video part is little clear, and I appeal to my children. I appeal to all the people who are all listening to this class. So kindly just do this activity in your home also, and you feel happy, show it to your brother, your younger brother and your younger sister, and show it to that and tell that so this is because of the concept of what refraction. It is due to the refraction of light. Okay, ठीक है. Now another phenomena, another illustration is nothing but twinkling of stars. You might have heard about the rhyme "Twinkle Twinkle Little Star." So this "Twinkle Twinkle Little Star," that poem is actually one physics teacher has to write that, because this is the effect of what refraction. Let us talk about that. It is because of the physics phenomena, it is because of the refraction effect. Due to refraction we can observe the twinkling of the stars. How, sir? How it is? That's the question mark. Now let us take about in simple form. I have shown you here one PPT. Look at this, my dear children. So this is called actual position of a star. So imagine this is the position of the actual position. Now you see you are standing somewhere here. I am putting the red mark. This is your position. Now, when light from the star, look at this, this is star, no? When the light from the star, this medium is called what? Air medium, or I'm sorry, we can say almost the air is very, very less. I can say vacuum. Okay. Here, the light is moving, or light from the star moving along a straight line, because in sixth class, our science teacher told from the source light always travel along a straight line. But 10th class, your physics are changed in a given, can you tell me? In a given medium.
Medium.
Very good, better, very good. Now, it is coming straight only, better, no doubt. So, it moves along a straight line because it is moving in a vacuum. The moment it enters our atmosphere, so here this, imagine this atmosphere. In atmosphere, there is our density will be different. What will happen, this light, and the interesting thing is that our atmosphere density is not uniform throughout the area. So somewhere near that one, no, topmost layer density is less, and near to the surface density is more. There is a difference in density. That is the reason what will happen, my dear children. The light that is coming in a straight line, it goes on continuously bending. It continuously bends and reaches the observer. Because of what? Change in density. Because of what? Change in slight change in speed. Because of what? The phenomena of refraction. But for an observer, for us, our eye always perceives better the light is coming from a straight line. It always perceives light is appear to be coming straight line. So, for us how it appears? The light is coming from a straight line, it appears as if. So the position is there, no. Position of the star is slightly changes. As is shown, your friend is there, previously one of your friend explained. So you see that one coin is there. This is what I am going to repeat. One bowel is there. This is your bowel, right? And you kept the coin. This is the original position. Position 1. This is original position of the coin. Now if you keep some amount of water, what happened? Its position is changed. It appears to be raised. So it's so this is called apparent position. So what is happening there here? The position of the coin is changed. In the similar way, my dear children, in the similar way, dear children, here position of the star also changes. You have to say position of the star beta slightly
Hello.
changes. When positions change, this is called flickering, this
Yes, sir.
fluctuate. So then because of this fluctuation, I'll say here, because of this fluctuation, then our stars twinkling. The effect of twinkling can be seen. Our sun is a very, very big, and of course they're located very far distance. You imagine many number of rays are coming, 100 rays, 1,000, like you can divide into that one. And the continuously position going on changing, so we can call as a twinkling of stars. The twinkle, twinkle, little star, it is due to what? Our physics phenomena known as a refraction of light. Okay, beta? And it's clear for you. Now, this is the one more slide to give you detailed explanation of that. So, look at this. This is a star. Light from the star is almost coming along a straight line. The moment it enters the atmosphere, now it continuously bends. The light continuously bends and reaches the observer. But for our eye, for our eye, the light always appear to me coming from the straight line. This is what apparent position. This is the real position of the star. This is what apparent position. So the position of the star, what happens? Fluctuates. The position slightly changes, and hence the star appear to be twinkling. Okay, this is a phenomena you can explain with the help of what, beta?
Sir, I will call you
Refraction
back in
of
15 minutes
light.
because I
Okay.
cannot use my
Now
laptop.
let us talk about one more. It's a common effect. Of course, I am for the more children are from Kerala. No, now today my class, observing there by many children are from Kerala students only, and you are having more experience. That's what I selected this slide because you like this, and fish and all, Let us take about that now during the summer camp and holidays, and you are just went to a near pond for fishing or some other time. You are enjoying that summer time. So, beta, look at this here. Now, if you this observe this pond and say a fish is there, this is called, I'll say this is the actual position of the fish. When there is no medium, when there is no change of media, what happened? This effect cannot be seen. Observe here, and this boy, is observing. Actually, the fish is located here, but for this fellow, fish is appearing little closer. This is the real position of the fish, and this is what apparent position. It is changed because of what refraction of light. This one we can call this as a real depth and apparent depth, which means I will make it more clear. So from this slide is very clear that let me take one object is kept inside the water like a fish inside the pond. Okay, okay. Now I'll come back. Right. Look at this. Look at this. But very interesting. I'm going to give a question and you have to solve that. Okay. Look at this. An object is there. I'm going to say this object is kept where. Tell me where the object is kept. Where the object is kept, beta?
Bottom.
Very good. Inside the water. Right. Now this is the real position. Let me take O is the object which is kept inside the water. Now the light from the object, the light from the object moving from which medium? Water medium to which medium, children? Air medium. Yes or no? Air medium. Wonderful. So whenever there is change of media, what will happen to light? Very good.
Bends.
Wonderful. It bends. So what is actually happening here? When light is moving from water medium to air medium, then the light bends. Okay? Light is bending and going like this. But for an observer, for our eye is always perceives. It is coming from the light is coming from a straight line only. So, but whereas for us, it point or the object appears. This is the position of the object. I'll say I means image. What is O? Or you can say is virtual position. This is what real position of the object. O is the real position and I is the virtual or apparent position. I is the word here, beta. Apparent position. What is happening there? Tell me. Looking at the slide, you tell me what is happening to the position of the object. For him, for an observer, position of the object is a little deeper or little closer.
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 Wonderful, very good, closer. That means you see in the previous slide. So for this person, actually fish is actual position is at O. O is the actual position of the object. But due to refraction of light, what is happening? Beta, its position is changed. So, and it appears little closer. That is the reason. If you go to a pond or is something, a river is having a lesser depth. If you see the bed of the river, you will see the bed of the ocean. I mean, pond or lake. Sometimes we can observe inside the pond or some stones are there. You feel that the stones or object appears to be little closer. It's because of what refraction effect. So because of the bending of the light. Okay, this what real depth. Actually, let me take here for example. So actually, fish is located. For example, fish is located. Let me take here for example, beta. Say something 50 centimeter. For example only, 50 centimeter depth. Like in, for example, here what happens to us, let me say, for us, for us, depth from where? From the top. From the top, in reality, fish is located 50 centimeter. But for say, for example, I am telling, for this observer, it for this fellow, it appears to be something 30 centimeter. For example, only, but it's less, no? It's a closure. That means the objects appear to be little closer than original location. I'll repeat. Object, क्या बेटा? Object appear to be objects appear to be closer than original location. Originally where it is the position is O, but what happened to us, it for us it appears very closer, very near, very little earlier. This is what real and apparent depth. Real depth is different. Real depth आपका टीचर ने बताया 50 सेंटीमीटर एग्जाम्पल. Apparent depth क्या हो गया? What happened apparent depth? For example,
Closer.
closer. Just like your teacher give an example of 30 centimeters. That means for an observer, for you, fish appears little closer. Am I right?
Yes, sir.
For you,
Yeah.
fish appear
Yes,
little
sir.
closer. Yes or no?
Yes, sir.
Yes, better. Thank you, better. Thank you for your response. Now, let me see here. Let me give that another example. Okay. So this is the one ray diagram to understand. So real and apparent depth. Nowadays, our NEP, National Education Policy, insists upon competency based education questions. Sometimes our children says, "Sir, it is not there, sir. Sir, this question not there in the textbook, sir. I have studied this Oswald book, sir. I have studied entire additional questions, sir. This question not there, sir. See, sir, so much difficult, sir." Like that, our children says. My dear children, our NEP wants to be more competent, more competent. See, look at this. What do you observe? Can anybody? Anybody can? Yeah. The slide is clear for you, beta?
Yes, sir.
Yeah.
Yeah.
So a little girl, a child, observing that is something you see with a grandfather or something like that, looking into the pond, and you see very clearly there are some stones inside, or some fishes, or some objects, and she just appears little closer. I'll go for one more example. This is some children that know a pond or nearby river. They're just closely watching the depth of the something, what the pebbles or some stones are there available. Little more clarity. Little more clarity. Look at this. So in this picture, you can see a pond. A small pond is there. Can you notice that here somewhere the stones are there? Can you see here this area? Yes or no, beta? Can
Yes,
I
sir.
identify? Yes.
Yes, sir.
Yes, and it's very clear that for you and for the observer, these stones are appear to be. Tell me how it looks. It is very deeper, very far, or very near. How it
Near.
appears to you?
Sir,
Near.
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 Very good. It
Yeah.
appears to be nearer. Wonderful. It appears to be nearer. It appears to be closer. Okay. Now this is the idea. Your teacher. All the teachers will teach in the classroom. Every teacher, no doubt about that. All the teachers will talk about that. What is this? Refraction and this and all. But what is a competency based question? I will tell you. I want to say answer from your side only. See, can any one of you read the question? Only one student read the question. Yeah, please, better.
Some of the kinds are with an attention
Kids.
intention.
Sorry for interruption. Some of the kids.
Some of the kids are with an intention to enter into the pond by thinking that Depth of the pond is less. A 10th class VJ student passing nearby noticed the children and suggested them not to enter the pond as depth of pond is more than it appears. Explain the values shown by the student and name of the phenomenon of light in this case.
Wonderful. Thank you. But unmute your mic. Thank you for helping me. Dear children, all the children, I think I don't know how many of in the class, maybe due to some technical issues, some may have left. But even then, who are all there, this is the way questions are there. This question will not be available in the textbook. This question will not be available in your, something reference books. See, these questions are called competency based questions. So the purpose of this question is to test that how reality, how much you understand the concept. And if you really thinking now, if you understand the concept, nowadays the question paper is very easy. Simply children are telling the question paper is very difficult, sir, हमको बहुत difficult हो रहा है ऐसे बोलते. It's not like that. In reality, question paper nowadays is very easier than the previous ones. So question goes, I repeat, some of the kids are with an intention, okay, beta, to enter into the pond by thinking that depth of the pond is less. But a 10th class VJ student, Vijnana Jyoti student, who is passing nearby, noticed that children and noticed the children and suggested them not to enter the pond as depth of the pond is more than it appears. This is the topic based on real depth and apparent depth. This is the concept based on which the concept, what is the topic beta? Refraction.
Refraction.
Wonderful, my dear
Refraction.
children. Now, can tell me what is the answer? Why? Why that Vijnana Jyoti, our Vijnana Jyoti scholar is guiding? Because that child knows that the concept of refraction. That child knows that position of the object changes due to refraction. Its apparent position. It looks very closer. Yes or no?
Yes, sir.
Yes.
Have you understood?
Yes, sir.
Yes, sir.
Sir.
Yes. Yes, good, but look at this.
Tell them
So,
JNV.
answers. Answers,
Which
please. I
JNV
just
the
told
given?
no. You are given. This is the concern towards the people and society. What are the values exhibited by student? The students are concerned towards the people and also and applying knowledge in daily life situations. What you learned in the books, you are going to apply that knowledge in your daily life. And what is the phenomena involved is none other than what the refraction of light. I hope you are understood. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, yes, better. Now, then, sir, only this much, sir. You told something, sir, that lemon look like bigger, or pencil is bending, or something advanced sunrise. Only because of you have to study. No, my dear children. The refraction chapter is a little bigger chapter, and we will also explain the formation of rainbow is a part of our refraction. And this visible light is the dispersion of light, dispersion of white light is a part of what refraction. And if you are having the problem, a slight defects, not a disease, I'm not using the word disease, I'm using the word defect. So some eye defects are there. So some children, what happened, sitting in the classroom of last bench, they cannot see the board clearly. Okay, they're having some refractive defects. See how beautiful, no? A refractive defect. So they are having some problem with the refraction of light. Their particular eye is there, no? Their eye is unable to refract properly. There is some refractive effect or defect. So to overcome that, we will use eyeglasses. Yes or no? Yes or no?
Yes,
Are
sir.
you using
Yes,
glasses? Some
sir.
of you using? Yeah, some of you people may be using
Yes,
the
sir.
glasses. So these are all the things to avoid, and this the thing is, no. So we'll study a little more, no, extra in the next classes. So one child asked a question, okay, that I'll try to attend. And before that, So still it is there in our brain. In our mind it is there. Why light bends? So that I will explain with one more video. I think this is
So I have a question from
can you listen to the voice and video?
Yes, sir.
Yes.
Yes,
Yes,
sir.
sir.
Yeah, please, all of you, please. I am not going to boring. So just one 5 more minutes. I will do only. I will take class and I will leave. Don't worry. Please be patient. 5 to 10 minutes only. Thank you, beta.
a named Srikant Mehato. He is from Purulia and she is preparing for JEE mains. And he says that, sir, I have also questions since class 7 or 8. That means between these 3 years to 4 years. When I read the chapter Light for the first time, my question is that why does the path of light bend when it passes through a medium? And then there are some other things. And then he says that I always take an example that if a body moving in a straight line and faces a medium that is denser than the second medium, then it will slow down its speed. Rather, it changes the path. My conclusion till now is fresh, that is question to answer this question. Right. So I take from the last sentence that she has written that if a body is moving in a straight line and it faces a medium that is denser than the present medium, then it will slow down. Light also when goes from optically clearer to optically denser, it slows down the speed. But then he said that okay, fine, speed increases, but why should it happen? But of the opaque distance, normal less less. The problem is that generally we think light as a ray, a very very thin ray, a combination of rays. That is an approximation. Sometimes it works well. But in reality, light cannot be treated as one single ray combination of something. And each ray individually we treat and say that is better than others. That because light has a huge property with another thing. So instead of a small object going, ask to be extended object, the width wise, going in some x direction, in y and z direction. Also, there is the light gap, the part. You cannot individually make a straight line and say that okay, light is going on this part of the other has no effect on size. Okay, so if you consider light as an extended object, then there is a very good analogy by which you can understand why should it bend when the student goes down. Let us look at the diagram. Let us car. Let's suppose it's a car. Let the front wheels and then the rear wheels and the front wheels. The car is coming from a line. What direction? Like this. And here are two different what kind of bumping board. Then there is speed here. Speed of car here will so if there is an oblique distance, that means that the line separating this side and this side is at some angle, then this diameter, this wheel will reach here and this will reach here. As soon as this wheel reaches here, but it is still going to get harassment. So what will happen? If this goes smaller distance, this wheel goes a smaller distance, and this wheel goes a larger distance, then if you connect, this is large, this is slow, then you connect.
11.
Originally, the line divided
Okay, so you started 11.
now it went
This
that
class
is
should
how
end
life
at
also.
usually
If
what it
light
happens
is on a
classes
single thing,
11,
then
9:30 to
you cannot
11.
treat
in 11th
light,
class.
and
But
therefore
11th class
part
we
of
have no
that
choice. That is why they
light will reach at one
make
position.
this.
Earlier, will slow down immediately, and other parts will be created, and then they will travel more distance and reach the path.
Tell her something. Ma'am, the students will join. They are in another session.
Okay, children, have you seen the video?
Good morning, ma'am.
Can you respond? Anybody?
Ma'am, you are not
Hello?
Yes,
listening.
sir.
Can
Yeah,
you
you
please
enjoyed the
mute?
video, no? See, actually, you see that is a JEE student actually preparing for
That is
JEE, and the
unnoticed.
student asked a question and the light bending, and the answer is given by beautifully by Sir H.C. Verma
Just
sir,
when
who
the
is the Padma Shri
light
awardee,
option, click on
right?
left.
And what's the simple way of explanation? You cannot treat the light as a single ray. You know, it is an extended object. You take the extended object, and with help of a beautiful example, and Sir has narrated
It's
why the
refraction.
light bends. I think it's
Good
very
morning,
good.
ma'am.
So, do you like this? You understand, children, little about refraction?
Yeah.
Yes, sir.
Okay.
Yes, sir.
With all your this one consent, with all your shall you go for one more class or don't want? Be
Yes,
frank, no
sir.
problem. Shall you go for one more class? Not today. Don't worry. Today I'm not going to
Let's
take you.
find our
Today I'm
class.
not going to take one more class. Shall you
Yes,
take
sir.
tomorrow, day after tomorrow?
Yes, sir.
Yeah. Yeah. One boy asked
Okay,
it.
sir.
One student asked a doubt, beta, that I should not skip. I must tell them. Are you ready? Only 2 minutes I will take, and then I leave you. One boy or one student, one girl, I don't know. One asked a
We tell
doubt.
you inside this
She asked
class,
me
the
a doubt
students are
like
in
that,
next.
sir, morning time, when sunlight is coming, no, the intensity of light is less, whereas noon time, the intensity will be more. Very good question. Very good question. It is something to do that intensity or illumination of light. Okay.
Ma'am,
To
you
explain that,
click
my
on
dear
slide
children,
show.
I need to take a simple mathematics.
No,
So for
ma'am.
this
You click on
actually,
share
imagine the
icon.
light is there. No, what is coming? The light intensity I. I is the intensity of light. A formula is there. We can say when the
Press
light
right,
falls
press left
normally
or
beta.
right click.
Normal
Yes.
falls. We can say, and suppose imagine. I'll make it little more like this. Beta. A surface. We say it is falling normally. This light is falling normally during what noon time,
Yes, yes,
daytime,
yes,
12 o'clock.
ma'am.
And what about the other
Yes,
one?
ma'am.
In the other time,
You can
other
go
time,
for
the light is falling like
slideshow.
this, like this. It's
Yes,
the
ma'am.
oblique direction. It is something to do with the angle. The angle is different. During our sunrise or sunset, what happened? So this angle is more. Now during noon time, what happened? A formula is there. Now it can be explained. I cos theta. This is a formula. The intensity of light depending on something, a function of cos theta, because the child asked a doubt, and it is my prime duty to clear. And it is of course trigonometry. One lesson is there for in mathematics. It will come
When the class is
when theta
coming,
is equal to
so
0 beta. That means for
apply.
normal incidence angle, here theta is equal to 0, cos 0 will become 1. Cos 0 कितना होता है 1 होता है. So when cos 0 1 becomes, that means intensity is more. So here when light falls perpendicularly, when light hits the surface normally, then the intensity will be more. The simple word I can say like this: when the hits light hits the surface normally, light is incident on the surface, perpendicular direction, where theta is perpendicular to surface I'm telling about. So here at a angle, that for the intensity, the formula cos I cos theta, theta 0, here intensity will be more. When you say here increase like this, if going on like this, when I'm going on changing the position, the rays, so angle will be more and more. And cos 90 beta, cos 90 0 rakano. So we'll say here cos angle may be 80, cos 85, like that. What I want to say here, intensity of light decreases. It is something to do that simple way I can explain. During noon time, the light is incidenting normally, and effect will be more. And here it is incidenting obliquely with much more angle, so its intensity is less. So that is a question posed by a child. I hope to some extent I convinced that child. So with this, I conclude my class and be there, be in the line only. So myself, Manohar Kumar, I'm working as a vice principal in JNU Udupi. And thank you, my dear children, for your patient listening. And I enjoyed, you are keeping a silence in the classroom, and you are so good enough to interact with me. Okay, and thank you once again. Thank you very much. I hope you
Thank you,
understood.
sir.
Thank you, sir.
Thank you, Manohar sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you very much.
Thank you, sir.
Thank you. Bye bye. Let us meet some more time.
Students, I request you to join the sustainability session now, please. I have forwarded the links already. Kindly join.
Thank you, madam. Samiha, madam.
Thank you,
And
Manohar sir.
how was it? Okay, na? It came out nicely, madam.
Sir,
What
it
about?
was great, sir. I have recorded the session and also taken screenshots.
Oh,
So,
okay, okay. Thank you, madam. Thank you for your. Please, thank you
thank you,
very
sir.
much.
Thank you,
Okay,
sir.
thank you. Thank you.